let's implement a stack with an array-based implementation. So not a link-based implementation, which you can also do, but we'll just focus on an array right now. So first, our private members will need an array of item with data type t. This is a template, so we'll just use t. And I'm going to make it a dynamic array. Let's also have item count, so we can easily just keep track of that. Also, I have a tester here set up. I don't have a whole lot of tests, but when we run it, at the moment, it's not going to run through any of the tests because I have exceptions here, but we'll have some way to kind of check the functionality. Okay, so for size, that should be pretty obvious. We just return the item count, and we have this array. We're going to need to allocate memory for it, and then possibly even need to resize it from time to time. So the resize function generally should be a private function. The outside user does not need access to the resize function. They don't know that it's implemented with a dynamic array. They don't care. They're just wanting to put stuff into the array. So we can implement that in a little bit. But for now, let's just implement some of these other ones. We're going to make sure the item count is set to 0 when the array is created. We're going to maybe set array to null pointer. And then down here, if array is not null pointer, then we will free that memory. So delete array. Okay, so let's also have something to just allocate array size for the first time. So int size, we'll say array is equal to a new t array of that size. While we're at it, let's also create a array size variable so we can keep track of that and know when we need to resize in the first place. So now if our item count is equal to array size, we know we need to resize the array. So that still builds. Okay, so mostly I'm concerned with the basic functionality here. We want to be able to push data onto the stack. So first we would want to make sure if has the stack been allocated. If not, we need to allocate memory. Or are we full? If not, we need to resize the array. So if the array is equal to null pointer, we need to allocate memory. And let's just set that to 100 for now. Or if item count is equal to the array size, then we're full. We need to resize, which has not been implemented yet. We'll just throw this in here. Otherwise, we can continue. So we don't need to return from the function. It's not a failure state if these happen. We just have to do some prep before we can actually add something to the array. So if we're looking at the array item, which element do we want to put the new data in? Well, it depends on kind of how you're designing this. We have just an array. We have 0, 1, 2, 3, 4, 5, 6, and so on. And depending on how you want to implement the top, we'll just say that 0 is the bottom of the stack, and whatever the item count is going to be the top. So we have item count, it starts at 0. We'll put item count here, and then we'll increment it by 1. So that after you add your bottommost item, then we'll insert at the position 1. That will be our next item, that'll be our item on top, and then we'll put in 2, 3, 4, 5, 6, and so on. Okay, so now at least our test for push, it might not get that far because of these other exceptions. We have create an empty stack, make sure size is 0, so that's just testing my constructor here. Create a stack, push 5, size should be, push the number 5, I guess. Size should be 1, top should be 5. So I haven't implemented top yet, but that part is failing. Okay, so now that we have that, how do we decide what to return as our topmost item? Well, one, we need to make sure that our array isn't empty. So if the array is set to null pointer, or if item count is 0, then we're going to have a problem. and we can throw some sort of exception. I'm just going to be lazy and copy this at the moment and say array is empty. We have other exceptions we can use, but I'm just going to leave that there for now. And if it is not empty, we can return the m array at the m item count -1 position. So let's go ahead and build, and now this one that tests the size on the top, those pass. Let's see, size should be 2, check the order. Okay, so the order isn't working because pop hasn't been implemented yet, but that's how we have top. Okay, and then for our pop function, all we have to do is reduce the item count by 1. So first, we want to make sure, is the stack not empty to begin with? If it is greater than 0, then we can go ahead and just do a lazy delete basically, and just decrement the item count. That way, whenever we need to add a new item onto the stack, it will be overwritten. So we don't actually have to like remove the value at that position. We just say, hey, the stack is a little bit smaller. So if I try to illustrate this in text really quick, let's say we have this is the bottom, this is the top. Let's say we have A, B, C, and D, and when we call pop, all we're doing is essentially taking this top and saying this is the top now. That's not the top, it's still there. When we go to push a new item in, let's say we're pushing Z, it'll just overwrite that item D. So there's no reason to actually clear out the data at that position, we just have to decrement the item count. Okay, so this might actually pass the tests without having resize implemented. We have those passed. Let's go ahead and quickly implement a resize, and we'll change the default array size to something really small so we can see how it works. So let's say we are only allocating 1 space for now, and then once we fill in that 1 space, we need to resize. So when we need to resize our array, we need to basically allocate more memory of a different size. So let's say temp array is a new array of t items, and let's take the current array size plus 10 or something like that. So we have some new memory allocated. Then we have to copy all of our data from the old array to the new array. For int I is 0, I is less than the item count, I++. Copy everything from the old array to the new array. So temp array at position I is going to be m array at position I. So we've copied everything over. Now we need to free the memory that the old array is pointing to. So we delete that. Now the pointer still exists. We can keep using the m array pointer, and we want to do that. So we'll set m array to point at the same location as the temp array. We need to make sure to increment the array size to the new array size we've done. So that, and then that should be fine. Let's go ahead and in here put a breakpoint and go ahead and watch it execute. So we're starting with one of the tests. We're creating a stack, push 5. We need to resize. So let's look at the m item count, which should not change, and we should look at the m array size. So we'll step into here. It's going to allocate a new array. So let's look at temp array. It has the address here. Let's also look at the m array. Its address is here. I'll go ahead and type in temp array down here too so we can see. Well, it's full of garbage right now, so we are going to iterate through and copy everything over. So the first item becomes A. That's all we have. We're going to free this. We don't necessarily need to set it to the null pointer because we're going to reset its address where it's pointing to right in the next line. So we've freed that memory, and then here we're going to copy the address over from the new array to the old array. So watch. These are now both pointing at the same place in memory. We are going to increment the item count to be plus 10, and then we're done. So that's how it works when we resize through that. Now that we have extra space, we can add an item at position 1, this new data, and increment the item count and so on. So that's how that works. And that's all that you really need for the stack with the array-based implementation. And if you want to see the tests, these are just the 4 little tests that I wrote to test out the stack. And we can see that everything's passing. We have the correct size when you first create one. When you add one item, it has the correct size. The top item is correct. Added 2 things. And then it pops everything to check, make sure the order is correct. So it's correct here. Pushing 3 items and popping, making sure that we have the correct sizes after each of those. So yeah,